All right. This is CS50, and this is Lecture 3. And today, the goal is to be a lot more algorithmic than code-oriented, and to really kind of come back to where we started in Lecture 0 when we talked about computational thinking and algorithms, because now you have a few weeks under your belt, and you have a few new tools and hopefully skills under your belt, even though odds are you're still getting comfortable with some of those skills. And so let's look then at this piece of hardware that we talked about a couple of times, and this is an example of what? Yeah, memory, or RAM, random access memory. And this happens to be pretty big on the screen, but it's actually pretty small if you were to find it in your Mac or PC, in your laptop, or some other device. And this is just memory. And so memory is places you can store information, numbers and characters and strings and bigger things still. And recall that if you want to use this memory, you need to address it. You need to put something in particular locations, and we're going to start doing this all the more. So in particular, there's at least like four black chips on here, which is actually where the zeros and ones are stored, and the green circuit board and the little gold connectors you see on the screen too. That just allows all of those black chips to intercommunicate ultimately, and for the zeros and ones to move around. But if we zoom in on just one of these chips of memory arbitrarily, and then zoom in here, you can think of this, wonderfully enough, as like a rectangle. Could be any shape, certainly. But if we think about it as a rectangle, we can divide this chip of memory up into like a grid like this. Completely arbitrary how I've drawn this. But the fact now that I have a whole bunch of small boxes, you can start to think of this as being one byte, and then another byte, and then another byte. And I coincidentally wrote 8 bytes across, but it could be any number. It doesn't really matter. And so you can start to think about these bytes as having specific locations or numbers or addresses, as we're going to start calling them. So if I zoom in on the top of this, you could start to think of the top left as being byte number 0, because computer scientists generally start counting at 0, and then byte 1 and 2 and 3 and 4 and dot, dot, dot. And then just as a refresher, in a typical Mac or PC these days, like how much RAM or memory would you typically have? For what? 4 gigabytes, and giga means billion, so that's 4 billion bytes. And maybe you have a little less, maybe you have a little more, but on the order of billions of bytes. So we're only scratching the surface of just how much storage there is and how many numbers and characters you can store. But the point is that we can address them in some way. 0, 1, 2, and so forth. So this is how we stored Stelios's name in memory. Recall this was an example last time where we needed to put the characters of his name somewhere. And so we actually put the S and then the T and then so forth, starting at the leftmost location on forward. But we also put something else. It's not sufficient just to put the letters of his name in memory. What else did we have to do? Yeah, the 0 command, or more specifically, the 0 byte, or the so-called null byte, NUL, and it's represented as \0. Because if you were just to type a normal 0, that would technically be a character from your keyboard. It looks like a number, but it's technically a character, a char. And so \0 literally means 8 0 bits in that byte's location. OK, so now that we had this ability to represent Stelios with a sequence of characters, null terminated at the end, we don't really need to worry about the hardware anymore, right? We can abstract away from that, just as we did in week 0, and not worry about how those zeros and ones are stored. We can just trust that they are somehow. And so we can abstract away and just start thinking about it as a sequence or a grid of letters like this. But that \0 is important, because it is the only way that this language we're currently using, C, knows where strings end. If you didn't have that, it would, printf, for instance, might just keep printing all of the contents, all 4 gigabytes of memory that your computer has, no matter what those characters actually are. And then, of course, you couldn't distinguish Stelios's name from Maria or someone else altogether in memory. So let me go ahead and open up the IDE just to demonstrate now what you can do with this kind of knowledge. Suppose I wanted to write a program that allows me to let a user type in his or her name, and then I just want to print out his or her initials. And for simplicity, I'm going to assume that the person's initials are whatever the capitalized letters are in the input they type. So I have to be a little nitpicky and type in my name properly. But with that said, let me go ahead and whip this up. So I'm going to save this as initials.c. Just out of habit, I'm going to start by including the CS50 library, because I'm going to want to get a string from the user. I'm going to go ahead and include standard io.h so that I can print something to the screen. And we'll decide later if we need anything more. I don't need any command line arguments for the purpose of this program, so I'm going to go back to our old version of main, where you just specify void, no argc, no argv. And then here, let me go ahead and declare a string called s and get a name from the user, as with quote unquote name and get string. And then what do I want to do after this? I want to go ahead and iterate over the characters in the user's name and print them out only if they're uppercase. But you know what? Rather than just print them out, you know what I want to do? I actually want to create a new string myself containing the user's initials. So I don't want to go ahead and just print out with %C one character after the other. Rather, I want to go ahead and store the user's actual initials in a new string so that I've got one string for their name and one string for their initials. And ladies and gentlemen, Ian. Sorry for the video glitches. Thanks. All right, so to be ever more clear, let me go ahead and rename this to name literally. And then I want to have a string for their initials. But we know what a string is as of last time. It's really just a sequence of characters. And a sequence is really has another name in programming. What is another synonym we've used for a sequence of something? An array. An array is that data structure we had when we started using square bracket notation. So if I actually kind of roll this back and break the abstraction, if you will, don't think about it as a string. What is a string? It's a sequence of characters. Technically, I could say char, and then I could say initials, and then I can specify however many letters I want to support in a human's initials. And by assuming we have a first name, maybe a middle name, and a last name, 3 characters should do it. 3 characters. So David J. Malin, like DJM, 3 characters. Is that enough chars? I'm hesitating because it's not, but why?
You need for the null character.
Yeah, so if we want to terminate even my initials, which isn't technically a word, but it's certainly a string, a sequence of characters, we need a 4th character, or we need to anticipate a 4th character so that whatever we put in the computer's memory is technically, in my case, like DJM \0. You need that 4th byte. Otherwise, you do not have room to actually terminate this string. So now, even though this doesn't look like a string insofar as I'm not saying the word string, it really is. It's a sequence of characters of size 4 that I can put characters in. Now, what are the characters in this array by default, have we said? When you just declare a variable of some size, what values go in it? Sometimes zeros. But generally, what's the better rule of thumb? Yeah, you don't know. It's so-called garbage values. You should not trust the value of a variable, generally speaking, unless you yourself have put the value there, or as by storing it with the assignment operator, or by manually typing it in yourself. So just to be clear, if I wanted this program to be kind of useless for anyone except myself, I could actually do this. I could go ahead and do initials bracket 0 gets quote unquote D. Initials bracket 1 initials bracket 1 gets quote unquote J. And then finally initials bracket 2 gets quote unquote M. And then lastly, and this is the thing you might forget sometimes, you actually need to do the /0 there. But of course, this is not at all dynamic, but I have in these lines of code now created a new string called initials. It's of human length 3, DJM, but the computer is actually using 4 bytes to store it. But this is not the point of the exercise, because we already asked the user for his or her name. I need to now figure what that is. So just logically, or algorithmically, if you will, what process could we use, given a name like David J. Malin, or Brian Yu, or anyone else's name, how could we look at that input and figure out what the user's initials are? What's the thought process? Let me go a little farther back. So David J. Malin, or any other name. What's the process? What do you think?
You could use a for loop to iterate through the characters in the name.
OK.
To
OK, good. So iterate with a for loop over the letters in the name. And you've done that before, or in the process of doing that for something like Caesar, Visionaire most likely. And then you can use something like isUpper. Or you can even do ASCII math like we did a while ago to actually determine, is it in the range of A to Z capitals on both ends? So we have a couple of options. So let me try to convert that to code. Let me get rid of the hard-coded name, which is just kind of nonsensical, but demonstrative of how we could store arbitrary characters. And now let me do this. For int I gets 0, I is less than the string length of name, I++. And then I'm going to do something like this. If the ith character in name is an uppercase letter, and I'm going to use a function that you might not have used yourself, but recall that it does exist. isUpper will return essentially true or false. This is an uppercase letter. So if this is uppercase, I'm going to go ahead and do what? Well, the story is not quite complete. It's not enough to just iterate over the names and the letters in the name. We now need to decide where to put the first capitalized letter that we find. It's obviously going to go in the initials array. But what more do I need to add to my code to know where in this block of 4 characters to put the first character D in the case of my name? Yeah? Initials I. OK, so if I do that, good thought. So let's do initials bracket I gets name bracket I. That would seem to put the ith character of name at the ith location in initials, which at the moment is perfectly correct because I is 0. And if I typed in David J. Malin, D is at the 0th location. So we're good. But there's going to be a bug here. Exactly. I is going to continue marching forward 1 character at a time through the entire name of the user, but you only want to index you don't want to keep doing that same amount in the initials array, because again, the initials is much smaller. So even as I moves through the user's name, you want to take baby steps, so to speak, through the initials. So how can we solve this? I can't use I, it would seem. OK, great. Let's do that. We need another variable. So I could put this in a few different places, but I'm going to go ahead and put it here for now. So int counter gets 0. I'm just initializing my counter to 0. And then as soon as I find an uppercase letter, I think I want to do this. Put it at whatever the value of counter is. And then there's one more step. What do I need to do once I, put it at the counter location? Exactly. Increment counter by 1. So I can do this in a few ways. I can do it very literally. Counter gets counter plus 1, semicolon. That's a little annoying to type. You could do plus equals 1, which is slightly more succinct. Or the ever prettier, plus plus, which achieves the same result. Fewer characters, same exact result in this case. OK, so now I think we have a for loop that iterates over all of the letters in the name. If it's an uppercase letter, it stores that letter and only that letter in the initials array, and then increments counter so that the next letter is going to go at the next location in the initials array. So if all that seems to be correct, ultimately, I want to do this. I want to go ahead and print out %s \n initials. I want to just print the user's initials. But there's one key step in this blank line that I should not forget. What's the very last thing I need to do? Yeah? Exactly. I need to put a null character at the end of the array. So how do I do that? Well, I have the syntax. And I think, I want to say end of array. But how can I do that? What value should I put here? Yeah. Yeah, I could do str length of name. Well, not of name. The initials, but now you kind of got me in a circular argument because I'm trying to, it's kind of a catch-22 now. I am trying to store a \n at the end of the string, but recall from last time, the way strlang knows where the end of the string is by putting the \0. So it's not there yet. So we can't use strlang, but we already have, I think, the solution. OK, so we could absolutely do that or almost that. It's not quite 4. One tweak here, yeah? In back, yeah. OK, good. So actually, so counter is, spoiler, counter is going to be the answer. But let me just fix this one bug here. 4 was the right intuition. But remember, if you have 4 characters possible, it's 0, 1, 2, 3 is the very last one. So we needed to fix that to 3. But even more general would be to put counter, because the value of counter is literally the length of the string we just read into the initials. And so if we want to terminate that string, we already know how many characters we've counted up. And in fact, it would technically be wrong to just blindly put \0 only at the very end of these 4 characters. Why? In what situation would that be logically incorrect? Yeah? If they have more than 3 initials, we really have a problem because we don't have space for anything beyond 3 actual letters and a null terminator. And there's another problem potentially. Yeah? Yeah, if they don't have a middle name, there's going to be only maybe 2 letters, first name and last name. And so you're putting the \0 at the end of your array, which is good. But what's going to be that third value, that second to last value in the array? it's just garbage, so to speak. And so it could be some funky character. You might get weird symbols on the screen. You don't know because it's just incorrect. The \0 has to go at the very end of the string. So let me go ahead, and if I've made no syntax errors here, let me go ahead now and save this and go ahead and do make initials. OK, so implicitly declaring library function strlen with type unsigned long. So there's a lot of words, only some of which I kind of recognize immediately. I could run this through help 50, which should be your first instinct on your own or in office hours. But let's see if we can't tease apart what the error actually is. What did I forget to do? Yeah. Yeah, I've needed the string library, which now I'll start to get into the habit of more. Anytime I'm using strlen, just try to remember to use string. Otherwise, you'll see that error message again and again. Maybe there's more errors, but I'm not sure. So I'm going to go ahead and just recompile. Because again, you might have more errors on the screen than you actually have in reality. But there is indeed one more. So similar error, but different function. Implicit declaration of function is upper. So that's, again, same mistake. I've forgotten something. Anyone recall? This one's a little more less common, I would say. Yeah?
You need the character type library.
Yeah, the character type or C-type library. So again, you'd only know this by checking the man page, so to speak, or reference.cs50.net, or checking your notes or whatnot, or Google. And so that's fine. It happens to be in ctype.h. Now, let me go ahead and recompile. Seems to work. So initials, let me go ahead now and type David J. Malin, enter. Seems to work. Let me try a corner case like Rob Bowden without his middle name, RB, and so it seems to work. This is not a rigorous testing process, but let's trust that we did at least get the fundamentals right. But the key here is that we broke this abstraction, so to speak, of what a string is, because if you understand that, well, a string is just a sequence of characters, and hey, a string must end with a \0, you can do that yourself. And this is what you can do in C. You can put characters anywhere you want in memory. You can put numbers anywhere you want in memory. And this ultimately gives you a lot of power and flexibility, but also, as you'll soon see, a lot of opportunities for bugs with this power. All right, any questions on that particular example? Yeah?
Can you explain the initials counter?
Sure. Sure, let's explain the initials counter, which is used here and is declared up here. So we essentially want to keep track of two locations. If my name is sort of this length, I'm going to start at the first character, D, and with I, iterate from D, A, V, I, D, space, and so forth. So that one just kind of marches on one step at a time. The initials array, meanwhile, is another chunk of memory. It's of size 4, somewhere else in that green silicon chip with all those black chips on it. And we want to move through it more slowly, because we only want to move to the next location in the initials array once we've put a capital letter in it. And that's going to be less frequent, presumably, unless the user typed in all caps. So in order to achieve that, we need a second variable. And you proposed that we use a variable called counter, but we could have called it j or something else. And so counter is initialized to 0, and it is incremented here anytime we encounter a capital letter. So it has the effect of literally counting the capital letters in someone's name, D, J, M. So it should be 3 at the end of those loops. And that's perfect because, as we realized earlier, 3 happens to be the correct location for where you put the \0. Even though it wants to go in the 4th location, the address of it, or the location, is technically 3. So we sort of solve multiple problems at once in this way.